So a commercial customer orders 50 gallons of a paint that consists of 35% red, 40% green, and 25% blue paints. So that's the composition, that's the recipe that they're ordering, but they want 50 gallons of it. The store will prepare the order by mixing 3 paint mixtures that they have available in large quantities. So they don't have pure red paint and pure green paint and pure blue paint available. If they did that, then it would be very straightforward to use, just make a recipe of 35% red, 40% green, 25% blue and add it together. They can't do that because what they have available is what I'm going to call here a reddish paint. That reddish paint it's a mixture of all 3 red, green, and blue paints, but its largest component is red. So it's half red, quarter green, quarter blue. Notice those 3 numbers add up to 1 or 100%. They also have a greenish paint that's 1/6 red, 2/3 green, that's the largest component is green, and 1/6 blue. Again, those 3 numbers add up to 1 or 100%. So they've got that. And then they have a bluish paint that has more blue than the other 2 colors, 1/5 red, 1/5 green, 3/5 blue. So those are their working mixtures. We want to know how many gallons of each of those mixtures are going to be added together, mixed together to get what the customer wants. So we have to be crystal clear on what are unknowns here. This is an easy one to go astray on. If you just start immediately trying to write down equations based on these numbers that you get, 9 times out of 10, it won't be the correct analysis because you got to think about what your unknowns mean. I'm going to go to the next slide here. I'm going to go to my whiteboard here and write down how we're going to define our variables. We want X to equal the gallons of reddish paint. That's one of the 3 things we need to figure out. How much reddish paint is the store going to need to add in to get what the customer wants? Y will be the gallons of greenish paint. Z, let's let that be the gallons of bluish paint. Now I'm going to summarize here what the customer, actually I'm going to summarize here what we've been told. The composition of this reddish paint from the previous slide is 1/2 red. So here this is red, green, and blue. 1/2 red, 1/4 green, and 1/4 blue. The greenish paint consists of 1/6 red, 2/3 green, and 1/6 blue. And the bluish paint is composed of 1/5 red, 1/5 green, 3/5 blue. I'm just summarizing the information given in a handy way so that I can kind of look at what I have all in one fell swoop. I don't have to keep going back to the paragraph of text to get this information. I'm laying it out for myself in a table-like way. It's an informal table. What the customer wants, we were told, what the customer wants 50 gallons, that's going to relate to the X, Y, and Z, of a 35% red, 40% green, and 25% blue. That's going to relate to red, green, and blue up here. So this is what we want to make right here. So, what kind of relationships can we express involving X, Y, and Z that are going to incorporate this information and allow us to figure out what those numbers actually are? Well, first of all, there's a very basic one. The three numbers X, Y, and Z have to add up to 50. So that's one thing that we can write down. Now, this is going to harken back to that earlier mixture of mixture problems that we did involving methanol. So the same idea comes in here. X and Y and Z all have, those three things are mixtures of red, green, and blue paint. So I can take any one of those components, pure red paint, pure green paint, and pure blue paint, and figure out how much, say I'm going to do red. So I'm going to write an equation involving red paint. How much red paint is involved in each of those things that I'm adding together, that the paint store is adding together? In X gallons, in the X gallons of reddish paint, the X gallons of reddish paint is half red. So if I take 1/2 times X, the gallons of reddish paint, I'm going to get the gallons of red paint that's in that stuff. Keep going. How much red paint is in the Y gallons of greenish paint? Well, Y gallons times 1/6 of it, because 1/6 of it is red. So 1/6 times Y gallons will be the gallons of red paint that's in there. How about the Z gallons of bluish paint? Some of that is red. It's 1/5 red. So 1/5 times Z would be the gallons of red paint in there. If I add those things together, that's got to give, be careful here, the gallons of red paint that is in the customer's mixture, in what the customer is ordering. The customer is ordering 50 total gallons, that's 35% red. So this has to equal 35%, 0.35 times 50. There it is. So we have another relationship between X, Y, and Z based on red paint. Well, you know what? We've got green paint involved in the three mixtures X, Y, and Z. So let's write a green equation, a green paint equation. The X gallons of reddish paint is 1/4 green. So 1/4 X is the green paint in there. The Y gallons of greenish paint is 2/3 green. You see the pattern, right? 2/3 times Y would be the gallons of green paint in that stuff. And the Z gallons of bluish paint is 1/5 green. And so 1/5 times Z is the green paint coming from that stuff. If I add those things together, that's got to be the amount of green paint that the customer is ordering, the amount of green paint that's in that paint that the customer is getting. And that's 40% of 50 gallons. So 0.40 times 50. And for all practical purposes, I'm done here. However, I do want to pause here for a moment. So normally, if I were doing this in my office, I would stop right here. I would write my system of linear equations. Well, I've got it written. I would write the corresponding matrix equation and solve it. And I'll do that in a minute. But what I do want to point out, and what is probably pretty obvious from what I've written here, is that there's a blue equation. I could write this, and this is true. If I add the blue paint involved in the three mixtures, yes, the X gallons of reddish paint is 1/4 blue, so 1/4 X, and the Y gallons of greenish paint is 1/6 blue, so 1/6 Y, and the Z gallons of bluish paint is 3/5 blue, so 3/5 Z. If I add all of that blue paint up, that's got to be the blue paint that's in the customer's order, 25% of 50, 0.25 of 50. So there are actually 4 equations in the 3 unknowns. But the thing is, you only need 3 equations in 3 unknowns, 3 independent equations in 3 unknowns in order to come up with the solution if it exists. And so I don't need that 4th equation. Really, if this makes sense, and it does make sense, that 4th equation is actually contained in the 3 that I just drew a rectangle around. Because I've got the total in the first equation, and then the red and the green in the second equation. So essentially, if I subtract the red paint from the total and the green paint from the total, I'll get the blue paint. So it's already in there. It's already there's enough information in the 3 equations that I have highlighted here to solve the problem. And let me say one more thing. If you're at all concerned about the fact that you could have chosen to write to do the red, green, and blue, let's say, and not to do the total, that would be fine. Any 3 of these 4 equations that I've written will be fine and will give you the same end result. So it doesn't matter which 3 of these 4 you pick. I'm just choosing the 3 that I've highlighted. So now I'm going to move on. Here's the first equation and the second equation. In the second equation, I just noted that, let's see, what did I do here? Oh yeah, no, that's true. Yeah, in the second equation where I'm adding up the red paint, I do just happen to calculate here that the 0.35 times 50, 0.35 times 50 is 17.5. So I wrote the 17.5 here. You could do that computation right in the calculator when you're putting in the matrix if you want. And then the third equation is right here, where the 0.4, looking at this part right here, the 0.4 times 50, that number that I wrote down, that expression that I wrote down earlier, works out to be 20. So you've got this form right here. And so this is the system. So that's the system that I wrote. And there's a 1 here, a 1 here, and a 1 here implied. And so 1, 1, 1 is the first row of the coefficient matrix. 1/2, 1/6, 1/5 is the second row of the coefficient matrix. 1/4, 2/3, 1/5 is the third row of the coefficient matrix. Let's put that into our calculator. It's a 3 by 3. And so the first row is 1, 1, 1. The second row is 1/2, 1/6, and 1/5. And the third row is 1/4, 2/3, and 1/5. So there we go. And then the column vector of constants, go into matrix, edit, and edit matrix B. It's a 3 by 1 column vector, and it contains 50 in the first row, 17.5 in the second row, and 20 in the third row. There it is. And if I go ahead and apply the calculational method, A inverse, the inverse of that coefficient matrix, times B, the column vector of constants, I'll get the column vector of unknowns. And that's right here. The column vector of unknowns, x, y, z, is equal to A inverse times B, and there it is. So x is 27.06, y is 18.53, and z is 4.41. And hearkening back to our definitions of x, y, z, the answer to the original question asked means that 27.06 gallons of the reddish paint will be needed, 18.53 gallons of the greenish paint will be needed, and 4.41 gallons of the bluish paint will be needed.